So this is another topic of chemistry, that is equilibrium constant and its unit. So as we discussed in the last video of chemistry, Kc is known as the equilibrium constant. Alright, so first of all, what is the use of equilibrium constant, like why we do have this, and some of the basic characteristics of it. Alright, so first of all, the equilibrium constant, figure out the ratio of reactant and product. What does equilibrium like the constant do? Figure out the ratio of reactant to product. Sorry, this will come here and this will be here. Like it figure out the ratio of product to the reactant. Yes, the concentrations of this. So what is equilibrium constant? Basically it is the ratio of product to the reactant, like the concentration of both of them. Alright, so the equilibrium constant, the temperature is only the single factor. Here you can write single factor that affects equilibrium constant's value is T, and T is for temperature. Like here, this means that equilibrium constant is independent of all the other factors except one, that is temperature. For example, if we increase the temperature, the equilibrium constant increases, and if we decreases the temperature, so the equilibrium constant decreases. So here are some factors, like some characteristic of equilibrium constant, and first of them is Kc only work in equilibrium. Only works in equilibrium. Alright, as it is Kc, K means equilibrium constant here, so of course this will only work in Kc, like except this equilibrium position, or you can say equilibrium state. If we use it, so it is not valid there. Alright, second point is it represents the concentration of reactant and product in mole per dm cube. Sorry, it's not minus, it's here. Alright, so as we have discussed the formula, Kc is equal to product upon reactant. So what does this mean? What Kc is telling us, Kc is showing us the concentration of product and the concentration of reactant here. Alright, third point is, the third characteristic is Kc is independent. Kc is independent of reactant and product concentrations. Alright, so we don't, like here the Kc is independent of either the product is more or it is less, or this is more and this is less. It is independent. It do not affect the Kc, or the it do not affect the Kc at all. The fourth characteristic is Kc varies temperature. As we have discussed here, the only factor that the affect equilibrium constant is temperature, and here the temperature only affect equilibrium constant except all. So the fifth point that we are discussing, Kc is a balance equation. Mean like the reactant, here the reactant and product has concentration equal. Like it is a balanced equation to get equilibrium constant. Equilibrium means like give me a minute. Equilibrium means the state where both reactant and product are equal. So here we need to, like, the reactant and product have same and equal concentration. So yes, Kc is balanced equation because it has same concentration of reactant as well as product. The sixth point that we are discussing here is Kc represents equilibrium position. Now, how Kc can tell us the position of equilibrium? So yes, it can tell us, for example, if Kc is greater than 1, the reaction is forward. Here we can say it is forward reaction. If Kc is less than 1, we can say it is a reverse, or you can say backward reaction. Like here we have the formula. So first you need to like put the product here, reactant here, you need to divide them, and then if you see that Kc is greater, so greater than 1 here, this product, so you can say it is forward. But if you see the Kc is less than 1 here after dividing this, so you can say it is a backward reaction. Alright, and if Kc is neither more, or you can say big, nor small, so it is an equilibrium position. Alright, so let's discuss the last point here, that is Kc. Yes, Kc is a constant of equilibrium. It's an equilibrium constant, and it is ratio of product to the reactant. Okay, so it basically tells us chemical behavior. Like here you can see it is telling us it is big or small, and as well as when we are like comparing Kc to Qc, so it will tell us the behavior of chemical reaction as well. So here this is all about Kc, and that is equilibrium constant.